Hello everyone, I am Shruti Vijayargi from BISP Solution, and in this video I am going to explain the regression analysis in Excel. Excel includes several array functions for performing linear regression. You enter function as array formulas and they produce array results. You can use each of these functions with one or several independent variables. So we are talking about the linear regression. Linear regression is a common statistical data analysis technique. It is used to determine the extent to which there is a linear relationship between a dependent variable and one or more independent variables. So there are two types of linear regression. The first one is the simple linear regression and the second is multiple linear regression. So the first I am talking about the simple linear regression. In a simple linear regression, there's a single independent variable is used to predict the value of a dependent variable. While in multiple linear regression, there are two or more independent variables are used to predict the value of a dependent variable. So the difference between the two is the number of independent variables, and both cases there's need of one single dependent variable. Okay, so I'm trying to explain it with the help of an example in Excel. How does this calculate in Excel? So this is our data. Here is the account balance, and here is the account balance for all the accounts, and there is a number of ATM transactions. That means how many transactions has been done from this account. And the third argument is the has debit card, which means that there is a debit card for this account or not. So 0 represents that there's no debit card, and 1 represents for the that they have debit card. And number of bank service, that means how many services this account has been used. So it will show that there is 4 services of bank will be used by this account, and 2 services by this, and so many. And at last it is the receipt interest, which means 1 is for getting an interest and 0 represents that there is no interest will be paid to this account. So first I'm explaining the simple linear equation. So I just only require one independent variable. So here is number of ATM transactions, which is for the which is independent variable, and account balance, which is the dependent variable. So in simple linear regression, what we have trying to do is one independent variable denoted by x. This independent variable, number of ATM transactions is represented by x, and y is the dependent variable. So we can say that y is dependent on x. That means account balance is dependent on number of ATM transactions. So here we want to identify is there any relationship between account balance and the number of ATM transactions. So that is done by the client. So the relationship will be represented by y equals to a plus bx. Here x is representation of number of ATM transactions, and which is independent variable, but y is dependent on x, and y is used for account balance. And a and b are the output of our regression. That means regression analysis produces these values for a and b. Okay, so first we will see that there is any relationship between account balance and number of ATM transactions using any chart. So I'm showing this with the help of an chart. I just select the columns from account balance to number of ATM transactions, then go to insert, and from scatter chart select the scatter. So this represents the relationship of account balance and number of ATM transactions. Here this shows that there is an increase, that if the account balance is increases, then the number of transactions is also increases. Here is the account balance and here is the number of ATM transactions. So whenever any account balance increases, then there is a chance that this number of ATM transactions also increases. So this chart denotes this things. Okay. So we find that there is any relationship between account balance and number of ATM transactions. Okay. So now we will calculate our regression with the help of Excel data analysis tool. For this, to the we just go to the data tab, and from here I'm selecting data analysis options, and from this analysis tools I just have to select the regression and then click OK. Now input Y range denotes the dependent variable, and I have the dependent variable is account balance. So I just click there, select the cell from this to this cell, and there is the input X range, and I just click on their number of ATM transactions to this cell, and then now the first checkbox labels, which represents that we are selecting this labels also. If I just click uncheck this box, then click OK, then it shows an error that input range contains non-numeric data. That means I have selected this and this cells which does not have any numeric data, it is a labels, and I just uncheck the labels. So it is required to check labels if you are selecting these cells also. Constant is 0 where we have two constants A and B. If I want that A and B should be 0, then I just check this. But I want to calculate the regression value for A and B, so I am not selecting and check this box. And confidence level is represented here 95%. That means you are calculating regression with the confidence level of 95%. The output options denote that if I select output range here, that means we are selecting from this cell, and we want our output in this sheet and with the cell we want. And new worksheet, that means I want my output in another sheet, and new workbook means that I want my output in the another workbook. Okay. And the last option here for residuals, residuals is nothing, is just shows an errors, and I'm not explaining residuals here, I'm just trying to explain you how to calculate regression in Excel, and so I'm not working on that. I just check the new worksheet and labels and then click OK. So what does this produce? It shows the summary output for this regression data, for what data I'm providing, and for this it calculated this. So the first thing it is the regression statistics has been shown here. Here R square means is the regression, and which is 0.64. That means it is 60% that you are able to explain. That means 60% you are able to explain from Y to X. Okay, so R square, that means regression, and it is 60% you are able to explain. Okay, and the argument adjusted R square is not required for simple linear regression. It is not important for simple linear regression. It is important for the multiple linear regression. So I will explain you this value for multiple regression, and but in this sheet it does not have any value, it does not required here, and here it is important that R square value. R square is important for simple linear regression. And multiple R is nothing but the correlation coefficient between Y and X, and this is the multiple R, and it is just a square of this value. That means it is a square of regression value. That means if I calculate a square of R square, then it comes this output. That means I just calculate using maths square formula and pass this cell as argument and then enter. So it will generate the same output which is produced by multiple of R, and that means these values are same. That means multiple r is nothing but a square of r value. And this is the standard error that will be the standard error, that it shows the standard error. And there is observation. This is the observation, that means how many observations we are using to calculate. So here I am using 10 observations, so here is the value 10 for 10 observations. Okay. And then there comes ANOVA. ANOVA is the most important for regression analysis, and also note that it is very important thing. It helps you in understanding how regression is doing. This is the main thing for simple linear regression. Okay, so the first is the DF, which stands for the degree of freedom. Is the regression is the number of independent variable. Here we have only one independent variable, which is number of ATM transactions. So here one denotes that how many independent variable you are using in your calculation. So I am using only one number of ATM transactions for the calculation, because I am doing simple linear equation in which only one independent variable is required. So here one denotes for that how many independent variable you have, and I have only one independent variable. Then we have residual and total. Residual is calculated by n minus k minus 1. This is used for calculating residual, where n is the number of terms, that means how many observations you are doing, and k is the number of independent variables. So residual will be calculated here. Number of transaction will be 10, and the value for k is 1, because we have only one independent variable, and minus 1. Okay, so this value is 8, which is here 8, which denotes for residual. And now total is nothing, it's just a number of terms or number of observations minus 1. That means number of observations I have 10, and minus 1, that means it is total. Okay, so this is your degree of freedom for all of these values: regression, residual, and total. Then we have SS, which stands for the sum of squares of for the values of regression, and MS stands for the mean sum of squares. And this gives, and there is a F, which is the F statistics value, and this gives you the significance of F. The value for this must be noted that it should be very low. The value for significance F must be very low. So here it is 0.004. It is a very low value. So this is very important for regression analysis, and shows that our regression analysis is good. If this value is low, and that shows that our regression analysis is very good. Okay, so this is how this first table denotes, and the next table provides you the coefficients. So we have two coefficients A and B. So A is for the intercept, and the value for A is 462, and B is the number of transactions, and here it is 91.57. So it says that the account balance will be 462 plus 91.57 into number of transactions has been done. That means 10 transactions. So we are calculating for every transaction. So hash, I mean to say that it is a number of transaction has been done. So this is our regression equation. What we have read, y equals to a plus bx. So this is the A 462 for the intercept value, and B is the 91.57, that is number of transactions, and hash denotes how many transactions has been done. So this is what is meant by the regression analysis. So it is not always that the output is always correct. It must be noted that it will show always the correct output. So here we have to notice that t statistics value and the p values. And also, rather not seeing the t statistics, it must be note that just see the p values, and also must note that the lower the p value, the better it is. So the p-values must be as low as possible, and significance of f also must be as low as possible. If both these values are low, that means our regression analysis is very good and it is correct. So here also p-values is also very low, and here it is 0.1 and here it is 0.004. So it means that our regression analysis is very much correct. So in regression analysis, it is required these two things are the necessary to check out your analysis is correct or no, not. So here both these values are very much low, so it denotes that our analysis and our calculation is going to be correct. Okay. So if you have any queries, you can ask me, and thanks for watching.